Okay, let's discuss about the fragmentation and MTU. So, path MTU discovery. So, consider in your network where we have the fragmentation is happening. So, how do you find it and how do you control it, the fragmentation, and what will the impact of the fragmentation? That's what that we are going to discuss in this video. First of all, that if you are a networking guy, right? So, a new guy to the networking, you will be like surprised with this term called fragmentation. What is meant by an fragmentation? Is this something that happens in the network? Yes, it does happens in the network. Usually because in all the networks, right? So each and every network will pass through some internet, will pass through some, the VPNs, like securely the traffic from end to end. So that time what happened? The end-to-end network will have not have the same, MTU across the each and every hop. Consider I have the user here connected. User 1 is connected here, and here I have the list of router. Okay, and here my server is connected. Okay, this is considered router R1, this is router R2, this is router R3. Okay, now the here when the user sends a packet, okay, with by default and the Ethernet is you all 1500 bytes, right? So now 1500 bytes of packet is receiving, but now here the my M2 is 1500 bytes. But in between the path, when we don't have visibility, let's say here the M2 is 1000. Okay, between this R2 and R3. So now what happens when the user sends a packet, he will send a packet of 1500 bytes, right? And it reaches to R2. This is the step one. Okay, once it reaches the R2, right? Now the packet size is 1500. Okay, but actually the packet only can travel 1000. So what happened? He cannot send the traffic. He cannot send the packet to this link actually. So what happened? They eventually, if you are not able to send, it will discard. Okay, but what router will do? It will do some mechanism called a fragmentation. It what fragmentation means? Split the IP packet into multiple chunks. IP packets into multiple chunks. Okay, multiple chunks, multiple small packets matching the outgoing interface. Okay, so this is what the fragmentation will be performed on this router. What it will do, now I have 1000 bytes, right? Now I have 1500 bytes. Okay, so in this case I can only send 1000, and you cannot send 1000 also because you can only send 980 bytes. Okay, plus you have the 20 bytes IP header. Yeah, 20 bytes header. So 1000 packets will be sent. Okay, first from R2 and R3. Okay, then what happens is, so in the destination, right? So in the destination one, and one more thing is, only the destination will be able to reassemble the packet. So in between anyone want to capture and reassemble, they will not be able to capture. Only the destination router will be able to reassemble this fragmented packet. So what happened is, like, now in order to inform the destination router, this is a fragmented packet and this is not the first packet. There will be like another 2-3 packet will be coming, and you have to club it together so that you'll be able to see the exact information that is sent from the source. So okay, so in this case the first packet, when I do a split, okay, 980 bytes I send plus 20 bytes is a 1000 bytes. What I will do, there is something called in the IP header called fragment bit, fragment, right? I flip the bit to 1, the fragmentation has happened. Okay, then what I will do, I will generate a identification number. Okay, let's say 9712. This is my identification number. Then I will set a tag called more fragment to 1. Okay, then I'll set the fragment offset. So this 4 bits that I will set in the IP packet after splitting into smaller chunks. Okay, the first packet has been sent from here to there, then it is passed to the destination. Then in the second packet, okay, in our case, we have to send only remaining 520 bytes, right? Again, this 520 bytes will be sent in a second, and it uses the same identification number because in order to assemble they should be part of the same identification number. Then the more fragment, right? There is no packet offered there, so the more fragment bit will be 0. Okay, and there will be a fragment offset will be there, value will be set. Okay, so then the packet will be sent from R2 to R3 to the destination. Once R3 receives this, the destination receives this packet, you based on the identification number, the offset and more fragment bit, right? So it will like assemble the packet and then open the information and check, and this is what the fragmentation means. So interviewer, we can explain this way to the interviewer in a detailed way, like more fragment, the identification number details, fragment set. So he'll be like amazed, oh, this new guy that is able to answer the the difficult question. Then he will ask you the next question, so what is the disadvantage of fragmentation? Disadvantage, right? So disadvantage, you can say each and every time when you do a fragmentation like this, the packet flow will be less. There will be a lot of time that it will the router will take to do the fragmentation. Also, a lot of process will take for the destination to reassemble it. There will be a lot of issues, right? Will happen in the fragmentation. In case if there is some bit is missed, some packet is missed in between, the destination will not be able to reassemble it. Then there will be an issue, right? So these are the disadvantages of fragmentation. So what are the ways that you can avoid this fragmentation, right? So there is something called, you can set a DF bit in the packet, in all the packets. What means do not fragment. This is when do not fragment. So which is available in the IP header. Okay. You can say do not fragment set to 1. Okay, means like when the packet comes here, what it will do? Is a fragmentation supposed to happen? He will drop because it's set with a do not fragment bit. Okay, so do not fragment bit will be set. So is there any other way that that the hint destination host itself will identify the path MTU and able to alternate the packet instead of 1500 bytes? Can I alter into like 980 bytes while sending itself? Yes, there is an option. So that's what we call it as a path MTU discovery. Okay, what this MTUD is, we can say like, okay, I didn't mention explain, right? Maximum transmission unit. Okay, so what this packet if the path MTU discovery will do is, now I have the host, right? Now it's connected to the router 1 R1, then next it is R2, next it is R3, then I have the server. Now what it will help is like, now the user is sending with now user is sending the packet now. Okay, they will enable the path MTU. The TCP packet, they'll enable the path MTU. Okay, now it will go to all the paths to discover what is the MTU on the path. Now it identify this MTU is 1000 only. Okay. Now this router, what it will do, it will reply with a ICMP exceed message saying that the MTU has been exceeded to here, to this guy, right? And now he knows that, okay, this MTU is this, what is the MTU based on the ICMP message. Now what he will do, he will alter the packet from 1500 to 900, like 980 bytes or something, right? Whatever after the header, right? So what will come, so he will change that to 980 bytes, and then he will transmit to the destination. So this is called the path MTU discovery will be done by the host itself. So this is the way that you need to answer your interview. So mostly the questions will be like scenario based like this only. So they'll ask you, give you a scenario, and I'll okay, what is if the fragmentation is happening? So how the fragmentation works, they will ask, okay, how do we avoid fragmentation? What is the disadvantage of fragmentation? So you can use this answer to question your provide answers to your questions in the interview.